What's up, everybody? Welcome back. Patrick here, moving on to another word problem on the test. So a cup of hot liquid was left to cool in a room whose temperature changes according to that function. So the temperature as a function of t, let's say t is minutes, is equal to 90 times 1 over 2 to the power of t over 30 plus 21. We have to sketch the function, and then we have to explain what the y-intercept and asymptote mean in this context. So to sketch this function, I'm going to just make a table of values. Now notice from this function we could tell that the half-life of this liquid is 30 minutes because it's t over the half-life and the base is 1 over 2. So what I'm actually going to do is I'm going to go up by 30 minutes for t. So I'm going to just plug in a bunch of points here. Let's maybe go up to 150. So that would be what? 2.5 hours, right? 150 minutes is 2.5 hours. And then I'm just going to plug in these points here for t. Notice how all of these are positive because we can't have a negative time. Now another way you could sketch this function is you can do transformations. So notice that we can rewrite this as 90 1 over 2, and then we can bring the 1 over 30 in front, so it would be 1 over 30t plus 21, right? So the a value would be 90, the k value would be 1 over 30, the d value would be 0, there's no shift left or right, and then the c value would be 21. And then your base function would be 1 over 2 to the power of x. However, you wouldn't use any negative values because we're dealing with time in this case. So you could do it with transformations as well. I just simply decided to do a table of values, but either way will work. So when we plug in all these numbers for t into the function, these are the corresponding temperatures that we get. So I'm going to take these points here and I'm going to plot them on this diagram. So here are the temperatures, the dependent variable, I went up by 10 degrees. And then the time for the independent variable, I went up by 30 minutes. Right, so let's plot these here. So 0 and 111, that would be up here. We got 30 and 66, so 30 and 66, so that would be where, like right about there. And then we got 60, 43.5, so that is like over here. So this is going to look like a curve, right? It's an exponential function, remember that? 90, 32.25, so that would be about there. 120, 26, somewhere there. And then 150, 23, about there. Now, this is an exponential function, so we know there's going to be a horizontal asymptote. Where's the horizontal asymptote going to occur? At the c value, at 21. So at a value of 21, we can actually draw a dotted line. I should have actually did that first, so this point should be actually above the dotted line here. Right, so this asymptote is at y equals 21, or t equals 21, at a temperature of 21. So when we connect all these points, it's looking something like that. Okay, so before you plot these points, I would recommend that you plot the horizontal asymptote first, so you know that all the points are going to be above it or below it if the function is below. I should have done that, but anyway, that's how this function looks like. So basically the temperature of this liquid is going down as time goes on. Now the question is asking, what does the y-intercept and the asymptote mean? So let's start with the y-intercept here. Well, the y-intercept, notice it's 111 degrees, and that basically represents the initial temperature of the liquid. Right, so maybe right after it finishes boiling. Right, so that's the initial temperature of when we start testing the liquid at a time value of 0, it's 111 degrees. What does the asymptote mean? Notice the asymptote is 21 degrees. So notice that this liquid, its temperature is going to keep increasing all the way to 21 degrees. So what does that mean? Well, it means that 21 degrees is the room temperature. Because if you think about it, if you leave a cup of liquid in a room for an infinite amount of time, eventually it's just going to be the same temperature as everything else in the room. It's just going to be room temperature. So that asymptote in this context, in this word problem of 21 degrees, it represents the room temperature.